Today, we're going to be talking about the anti-inflammatory proteins in honeybee venom. Our main subject today is the Apis mellifera. The Apis mellifera is a species of honeybee that has its name given for their ability to make large amounts of honey and are highly revered to be one of the main pollinators in the U.S. They are not local to the United States and originally came from the European regions. They are commonly known as either European honeybees or Western honeybees. The honeybee has a modified ovipositor that they use to defend against intruders and attackers of the hive. The stinger has barbed hooks on the sides of it so that it may get stuck in the flesh of whoever they're attacking so that they may pump more venom into the attacker. Honeybee venom is comprised of a wide variety of different proteins, with 88% of it being water. With the main proteins that are commonly used for different medical practices are phospholipase and melatonin. Melatonin is associated with having anti-inflammatory properties, has been commonly used in dealing with inflammation in humans, treating burn-like pain, treating blood clots, and have been used in aiding in dealing with cancer. Now our question now is, how can these proteins provide anti-inflammatory properties? An experiment has been done over the swelling of mice's limbs after a burn. There was 4 different substances being tested, with 6 groups in total being experimented on. Each group had a burn-induced tissue damage on one foot, and each group were tested with a different amount of bee venom. Group 1 had the naive group, Group 2 had the control, Group 3 had 0.01 milligrams of bee venom, Group 4 had 0.02 milligrams of bee venom, Group 5 had 0.1 milligrams of bee venom, and Group 6 had acetaminophen, with the results being that bee venom had a significant increase with suppressing the sub-P in the nervous system that causes inflammation. They further emphasized these results by taking pictures of the mice's feet and comparing them to each other. They showed that the ones who were treated with the bee venom showed that they actually reduced in swelling and even healed faster, further proving their point on how bee venom, when concentrated, can help stop inflammation. Another experiment has been done to see if bee venom can inhibit different pro-inflammatory signal pathways. This was done by filtering the bee venom through different means each time and finally made into a powdery substance, which contained both melatonin and phospholipase 2. I-nitric oxide mRNA is the protein that is responsible for producing high amounts of nitric oxide, the main substance in the initiation of inflammation. Steady injections of bee venom has shown to suppress the expression of this mRNA through animal modules. They further show this by putting this on a graph and allowing us to see how the bee venom actually helps with suppressing the INOS mRNA expressions. From these tests and experiments, bee venom has been tested over a multitude of different diseases and sicknesses that are caused by inflammation proteins. Adding onto our knowledge of bee venom abilities of suppressing different signal pathways have opened a new light in being able to experiment and treat a wider variety of debilitating illnesses, giving us a better understanding of what could be done to help treat those who are inflicted with these crippling ailments. A large study was done in 2015 over the anti-inflammatory effects in multiple different fibrosis-causing sicknesses. These sicknesses included liver fibrosis, atherosclerosis, and acne vulgaris. Their study showed that certain proteins from bee venom has been found to be able to inhibit certain actions in these inflammatory diseases, with bee venom regulating pro-inflammatory cytokines in the liver fibrosis animal model. In the atherosclerosis animal model, bee venom showed to have suppressed inflammatory reactions. Bee venom even regulated the inflammation signal pathways for the inflammatory skin disease, acne vulgaris. These studies have shown that there is good evidence of there being possible benefits to the treatment of multiple inflammatory ailments after harnessing certain proteins from honeybee venom, allowing us to possibly use the venom for medical therapy. in treating these ailments. What I found significant was how I could tie this back to knowing how the bees use their venom and learning what proteins make up the bee venom and how they use it in their daily lives and how we could use it in our own. And be able to see how bee venom can help with curing ailments that are caused by inflammatory proteins and already shown suppress different proteins that cause a multitude of different sicknesses such as cancer, arthritis, and fibrosis, and even has allowed me to learn what proteins we can use in order to help benefit ourselves and our health.